Statistics and probability are sections of mathematics that deal with data collection and analysis. Good day and welcome everyone to our first day of schooling in the second semester of school year 2020-2021. Probability is the study of chance and is a very fundamental subject that we apply in everyday living. While statistics is more concerned with how we handle data using different analysis techniques and collection methods. These two subjects always go hand in hand, and thus you can study one without studying the other. Today, we are going to explore random variables, for this is the first topic in statistics and probability. But only we will highlight the discrete random variables first, and for our next lesson, we will tackle the continuous random variable. In here, you will learn how to illustrate a random variable, classify random variable as discrete or continuous, and find the possible values of a random variable. Okay, are you ready? There are times in your life you don't value the time and your loved ones sometimes. You take it for granted because all you know, your parents are there, connecting the ends to fulfill your daily and future needs all the time. You don't even worry what things come after because you know your parents will supply your needs even though how much selfish you are or lazy you are to think of ways to sustain yourself. As days will pass and times gets older, sooner or later, you will realize when you go home like this.
What's the matter, Mama?
I'm dying, Forrest. Come on in, sit down over here.
Why are you dying, Mama?
It's my time. It's just my time. Oh, now. Don't you be afraid, sweetheart. Death is just a part of life. Something we're all destined to do. I didn't know it, but I was destined to be your mama. I did the best I could.
You did good, Mama.
Well, I happen to believe you make your own destiny. You have to do the best with what God gave you.
What's my destiny, Mom?
You're gonna have to figure that out for yourself. Life is a box of chocolates, Forrest. You never know what you're gonna get.
Mama always had a way of explaining things so I could understand them.
I will miss you, Forrest.
She had got the cancer and died on a Tuesday. I bought her a new hat with little flowers on it.
This is a favorite quote of mine, as well as many others who have seen the Hollywood box office hit Forrest Gump. His mother is already dying when the son returned home. Did you hear the mother say that death is an inevitable part of life? I didn't realize that I was destined to be your mama, as she said, but I do the best I can, which I mentioned earlier, that your parent will go to any length to provide you with the best possible care while they are still alive. So never lose sight of the fact that they are there for you every day, sustaining you in expectation of a better life someday. Return a little favor to them just to make them happy. A kiss, a hug, or even attending to their needs when they return home exhausted, etc. Because of your affection, it will make them very, very happy. You have to make your destiny, Mama said in another voice. And the son answered, "What is my destiny, Mama?" "Life is like a box of chocolates. You'll never know what you're going to get," says the mama. This is analogous to chance, in that you never know what kind of chocolate you'll get until you make an educated guess. Better planning is preferable to no planning and relying on guesswork. According to Joseph Porter, who is a retired adjunct professor of philosophy, answered this quote in May 19, 2016. And I love how he said, "When you open a box of chocolates, there's a variety of flavors available. Problem is, since they are covered in chocolate, you can't really tell what any given piece of chocolate is going to taste like. You're going to eat a chocolate. You know you are. Admit it. You want chocolate. But you won't know what you are getting until you bite into it. And then it's done. Like it or not, you tasted it. You never know what life is going to give you, but you live nevertheless. So every day, every new experience is something you really don't know about until you actually live it. It may not be an experience you like. It may be the greatest experience ever, but you don't know until you live it. And by then, it's too late to not live it. The real lesson, you take what life gives you and you learn to deal with it, whatever circumstances it will be. That is the probability of making the right choice for any circumstances. Okay, this is our first activity by tossing 3 coins. I will show you first, or clarify you first, a coin. This is a coin, 1 peso coin. Okay, one side of the coin is what we call the head. It represents variable h, head. And the other side of the coin, okay, let's say it will represent the tail, which the variable we use is letter T. Okay, again, one side of the coin will represent head, which represent variable h, and the other side of the coin that represent tail, we use variable T. Okay, supposedly, since we are doing the experiment of using 3 coins, I will add another the same coin. Okay, I will add another the same coins, so there are 3 coins. So we're going to conduct an experiment by tossing these 3 coins all together, and what will happen if that will land on the floor, if that will land a head, tail, head, or tail, 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 or head, tail, tail. Okay, I'll toss my first toss. Let me see. Okay, it lands tail, another tail, and head. Okay, so it means to say the first toss we have tail, tail, head. Okay, next toss I'll pick up another the coins, then I'll toss it again for the second time. Let us see. Okay, so we have, it comes out 1 coin, it comes out head, the second coin come out tail, and the third coin come out tail. So means to say head, tail, tail, or H T T. Okay, third coin, third toss rather. Okay, third toss. You see, Okay, it comes out tail, another tail, then another head. Okay, so let us fill this up in a table. So this is the outcome of activity 1, tossing a 3 coins. Okay, when we toss a coin, there's a possible outcome that all of the coins will land tail. So we have here tail, tail, tail. And the number of tails that will come out are 3. And the probability of coming out tail is 3 out of 3 coins. Okay? So, next, toes, we have tail, tail, head. And how many tails coming out on the second toes is 2. 2 tails. Tail, tail, head. So, 2 tails that comes out. And the probability is 2 out of 3. Next toes, the third toes, we have tail, head, tail. And the number of tails that come out, we are only particular to the tail, are 2 tails. And the probability of coming out tail is 2 out of 3. So this is how you're going to write in probability. Okay? So next, the fourth toes. The first coin come out head, and the second and third coin come out tail. So number of tails coming out, 2. And the probability of coming out tail is 2 out of 3. Okay, next, the fifth toes. The first and second coins come out head, while the third coin come out tail. So the number of tails coming out is 1, and the probability of coming out tail is 1 out of 3. Six toes. We have the first coin head, the second coin tail, and the third coin is head. So the number of tail that comes out is 1, while the probability of coming out tail is 1 out of 3 coins. 1 meaning 1 coin that come out tail out of a total of 3 coins. That is how we interpret. Okay. The the seventh toes, the first coin come out tail, the second and the third come out head, and the number of tails coming out is 1 out, and the probability is 1 coin that come out tail out of 3 coins. And the last possible outcome, all 3 coins come out head, no tail, only all head. So the number of tails coming out is 0, and the probability of coming out tail is 0 out of 3 coins. So means to say, no tail that come out, all are heads. So there are possible values of the random variable that will come out tails are, we have here 0, 1, 2, and 3. So these are the possible values of the random variable. How risky, okay, are you if you're going to ride an airplane? Okay, if you will not wear face mask. Okay, so this is you. This represents you. You're sitting here. Okay, but you don't know your 3 companions. Okay, but I will tell you their background. This is Anna. Anna is a passenger that is sitting beside you on the right side. Okay, she has a direct contact of his relative, of her relative rather, that has a COVID virus. Okay, she tested positive, but she refused. She still embarked a plane and seated at the right side of yours. Okay, this one is Matthew. Matthew sitting at the back of you. Matthew is sitting at the back of you. Okay, he is a frontliner. He is working in a hospital, but he obeyed the rules. He's very he is very he follows the order of wearing the PPEs in assisting the patient. And he tested recently. He is negative of the virus. This one is Matthew. This one is Ruben. Ruben is sitting at the left side of you. Ruben just tested, do the swab test, and the result is negative. Okay. Now, the question is, in how many ways Anna, which is positive of COVID, in how many ways Anna will infect you if in case she will transfer from one place to another beside you. Okay, so she's seated here at the right side of you. Okay, that is one out of three ways. Okay, Anna sitting at the right side of you, this is one out of three ways she will infect you with the virus if you will not wear face mask. Not only you, but also Matthew and Ruben, because they are not wearing face masks. Okay, what if Anna will transfer at the back of you, and Matthew will transfer here, and Matthew will be here on the left side, Ruben will be on the right side. That is another way that Anna can transmit you the virus of COVID because you're not wearing the face mask. So, one out of three. So next, what if Anna will transfer on the left side of you, then Ruben will be at the back, Matthew on the right side. Still, this is another way that Anna could infect you. So there are three possibilities that Anna could infect you. In any place around you, he can infect you because you're not wearing face masks. Let us write this on the table. Okay, in activity 2, this is the following outcome. Okay, so the first arrangement is Anna is on the right, Matthew on the back of you, and Ruben is on the left. So number of ways Anna could infect you is one way beside you. Okay, the probability of you will get the virus from Anna is one out of three ways. Three ways means to say these are the locations that Anna will relocate from one place to another. Okay, the second arrangement, Anna might transfer at your back, Ruben is on your right, and Matthew is on your left. Again, that is another way, okay, that Anna could infect you. And the probability of you will get the virus from Anna is one out of three. And the third arrangement, if Anna will relocate on your left, then Matthew is on your right and Ruben at your back.
Again, the number of ways Anna can infect you is one way, and the probability of you will get the virus from Anna is 1 out of 3. So the possible way Anna might infect you with a COVID virus is in every location as specified in this problem. I hope you understand. Okay, so we're done with the discrete random variable. Let us try example of continuous random variable. So we have here an example tossing a coin. So we could get either heads or tails. Okay, let's give the values of heads as 0 and tails as 1. So we have the random variable x. It can either be 0 or 1. So it depends. We could choose any heads. We could choose 100 or a tails of 150 or other values if we want. It is our all choice. Okay? So that is continuous. An example of continuous random variable. Another example like this. Fatima alarm clock is battery operated. The battery could fail with equal probability at any time of the day or night. Every day, Fatima sets her alarm for 6:30 a.m. and goes to bed at 10 o'clock p.m. Find the probability that when the clock battery finally dies, it will do so at the most inconvenient time between 10 o'clock p.m. and 6:30 a.m. As you read this problem, still this is an example of continuous random variable because each battery we do not know how many days it will last. Okay, it's always depend. So that's why the value here is not fixed, it's infinite. Okay, that's why this problem is an example of a continuous random variable. Okay. Another example of a continuous random variable is example number of leaves on a tree. There's no definite answer to this because in one tree there are lots of leaves. Okay, so this is an example inf of continuous random variable. Okay, let us go back to our activity one, tossing at 3 coins. Okay, let us analyze more further with regards to the outcome in the table. Okay, so let us interpret this one. What is the likelihood that all coins will land on their tails after being tossed? Okay, so it means to say all 3 coins should land tail. Okay, so we have 1, 2, 3, all tail. So there's no more other three of tails, so there is only one chances out of eight. 1, 2, 3, 4, 5, 6, 7, 8 that will come out tail. Okay, the right answer is 1 out of 8 chances. Let's proceed to the second question. What is the likelihood that at least one will come out head? Okay, at least one will come out head. This one head, one head, one head. This one, 2 heads, 2 heads, 2 heads, 3 heads. No, no, they are not included. So, what is the likelihood that at least one will come out head? So we have here 1, 2, and 3. So the answer is 3 out of 8 chances that will come out head. Next, third question. How likely is it that after tossing 3 coins, all of them will land head first? Answer is 1 out of 8 chances. Again, how likely is it that after tossing 3 coins, all of them will land head first? So there is here, all of them are head. So there is 1 out of 8 chances. And lastly, How likely is it that at least one of the three coins will land on tail? Again, I repeat, how likely is it that at least one of the three coins will land on tail? Okay, so we have here one, two, three. Okay, so the answer is 3 out of 8 chances. Okay, let us go further with activity 2, the ways that we can acquire the COVID virus without wearing a face mask. Okay, so we come out a result of the outcome. Okay, so the question here is how likely is that you will be infected with the COVID virus while you are taking a plane from Zamboanga to Davao? Assume three strangers who you do not know will sit beside and behind you on the plane, and one of it is a carrier. One to your left, one to your right, and one to your back. So, based from our result, the number of ways, all of them are uniform, one out of three ways. So, in every location Anna will sit, you will really get infected of the COVID virus if you will not wear your face mask. Okay? So, this is the Philippine Red Cross COVID-19 response. And it interests me because it shows the information how risky we are in doing or in attending this gathering. Okay? So it indicates here from our example last time about the sitting arrangement in a plane and one of the passenger Anna has a COVID virus. Okay, actually traveling by plane it is moderately high. Okay, in the scale of 7. Okay, so now let us proceed to the conclusion. How important is it in our lives to learn random variable? Okay, so based on my findings, I want to show you this what I have researched. Okay, so these are the things that the people commented. How are random variables used in real life? Okay, so we have here uh, one of the commenter, which is every Nesechu. This is speeches as a PhD statistical signal. So this is his comment. Polling. Okay, we have Zakaria Hashmi. You can just make uh, a quick reading on this comment. Okay, Chad. Random variable is a numerically valid variable which takes on different values with the appropriate example. Use of random variable in real life. The return on an investment in a 1 year period, the price of quality, and so on and so forth. Mutual funds, we have here number of answers for these questions. Quality reliability. Okay, so let us remember the keywords that we learned in this lesson. Okay, so we have here the sample space are the set of all possible outcomes of the random experiment. So as you see in our previous examples, the list or the number of ways or the number of arrangement, these are what you call the sample space, the possible outcomes. We have random sample or sampling is a part of the sampling technique in which each sample has an equal probability of being chosen. Okay, we also have encountered word discrete random variable. These are countable number of possible values wherein the probability of each value of a discrete random variable is between 0 and 1, and the sum of all the probabilities is equal to 1. So remember this. We have the continuous random variable. It's a random variable where the data can take infinitely many values. Okay, so take note also thesaurus word or other words for probability, because these are the words that is being used sometimes in civil service exam, college entrance exam, or the professional board exam. So the other word for probability is anticipation, chance, contingency, expectation, feasibility, odds, possibility, prospect. So chances, these are more closer in the meaning of probability. So do not forget this one because sometimes they use this word in word problem with regards to probability. Okay, so let us try to practice some exercises that was taken from the questionnaire in the civil service exam and other professional board exam, and also as well as the college entrance exam. So we will practice it today. Example: the pair of dice is rolled. How many possible outcomes are there? Okay, I give you few minutes to answer this question. What is your answer? A 6, B 12, C 16, D 18, or E 36? The answer is E 36 because each pair of die is 6. Each die is 6, 1 to 6. So there are two dice, so therefore 6 times 6, that will give you 36 possible outcomes. Let's proceed to the next question. How many kinds of goodie box can you make with 3 kinds of candies, 2 kinds of toys, 2 kinds of pencils, and 3 kinds of sticker papers? What's your answer? Okay, the answer. There are 36 kinds of goodie bags all in all. Okay, next question. How many kinds of meals can you get from 3 appetizers, 5 drinks, 2 desserts, and 6 main courses? The answer is 180 different meals all in all. Next question. A bag contains 3 blue, 3 red, and 1 green. What is the probability of getting a blue, a red, a blue or red, a green or red? Okay, the answer is getting a blue, it's 3 out of 7. Getting a red, it's 3 out of 7. Getting a blue or red, it's 6 out of 7. And getting a green or red, it's 4 out of 7. Next question. How many different outfits can you form from 3 shirts, 2 skirts, 2 pants, 1 pair of sandals, and 2 pairs of rubber shoes? The answer, there are 36 different outfits to be formed. A box contains 5 red balls and 8 violet. A ball is removed and another is drawn. What is the probability that the first ball is violet, the second ball is violet? Both balls are the same color. First ball is violet, the probability is 8 out of 13. Second ball is violet, the probability is 7 out of 12. Both balls are the same color, the probability is 14 out of 39. These are the answers. Next question. Okay, tell me whether this is discrete random variable or this is a continuous random variable. A number of defective computers produced by manufacturers. Discrete or continuous? The answer is continuous random variable. Next question. The weight of newborns each year in a hospital. Is this discrete or continuous? The answer is continuous random variable. Next question. The number of siblings in a family of a region. Is this? The answer is discrete random variable. And letter D, the amount of paint used in a building project. This is a continuous random variable. Letter E, the number of dropouts in a school district for a period of 10 years. Answer is discrete random variable. I already posted this quiz, short quiz, and you can answer this in Google Meet. Okay, then the link is provided under the YouTube description of this lesson. You can click on that link below. Just look on the description. So I have also another link that I provide for you to answer the assignment. Okay, so any question, just go on the comment section and you can write your question there. Okay, thank you and have a nice day to everyone.